Morning, everyone. Welcome to Introduction to Logic, Deductive and Inductive Reasoning. We are already at our 16th week, and for week 16, our topic is about the categorical syllogism. So for this week, we will understand the structure of categorical syllogism, the valid and invalid form, as well as the structure of the Venn diagram as well. So in order for us to furthermore understand our week 16 lessons and topics, I will show you a video discussion in our PowerPoint presentation that I have searched in YouTube as well. So I will just post the video links also for you to watch it again. But I will play it here on our PowerPoint presentation.
Another method of symbolizing categorical propositions is the use of the Venn diagram. John Venn, who introduced the method, thus the name Venn diagram, used two overlapping circles to represent the relationship between two classes. Consider these diagrams. The shaded portion represents a class that has no members, while the area with an X signifies that the class has at least one member. Generally, this is what a Venn diagram looks like, where this is read as S but not P, and this represents the class of things that are part of S but are not part of P. And this is read as not S but P, and this represents the class of things that are part of P but are not part of S. And this is read as S but P, and this represents the class of things that are both parts of S and P. Now, let's discuss the Venn diagrams that are used to represent the four standard types of categorical propositions. Here is the Venn diagram for universal affirmative A propositions. The shaded area of this Venn diagram represents a class that has no members. Thus, in the Venn diagram for a universal affirmative A proposition, the area S but not P is shaded to indicate that all members of S are members of P. Thus, we say all S are P. Next is the Venn diagram for universal negative E propositions. The shaded area of this Venn diagram represents a class that has no members. Thus, in the Venn diagram for a universal negative E proposition, the area S but P is shaded to indicate that this class has no members. Thus, we say no S are P. Then we have a Venn diagram for particular affirmative I propositions. A particular affirmative I proposition asserts that there is at least one member of S that is a member of P. This is diagrammed by placing an X in the area S but P, which is common to the two classes. Thus, in the diagram, we place an X in the area S but P, and we say some S are P. Now, here is the Venn diagram for particular negative O propositions. And so, a particular negative O proposition asserts that there is at least one member of S that is not a member of P. Thus, in this diagram, we place the X on the area S but not P to indicate that, indeed, there is at least one member of S that is not a member of P. Thus, we can say some S are not P. Now, in traditional or Aristotelian logic, one assumes that universal affirmative A and universal negative E propositions have existential import. Thus, in the example, all angels are holy, one assumes that there are angels and that all of them are holy. However, in applying the Venn diagram, one does not make this assumption. In the Venn diagram, all angels are said to be holy only if there are indeed angels. But the Venn diagram for a universal affirmative A proposition does not contain an area in which there is a symbol to show that there is an angel. Hence, the propositions all angels are holy or no angels are holy are non-existential propositions. In the first place, there are no angels in reality. This Venn diagram demonstrates this point. As we can see, both application of traditional rules and use of the Venn diagram presuppose that only particular affirmative I and particular negative O propositions have existential import. Thus, a Venn diagram for the particular affirmative I proposition, some angels are holy, contains an X to show that there is at least one angel that is holy. And this is how the Venn diagram looks like. A Venn diagram can be used to show the validity of categorical syllogisms. 3 intersecting circles are needed to diagram a categorical syllogism. 1 circle for each class. The following rules will be observed in testing the validity of syllogism using a Venn diagram. Rule number 1. The universal premise should be diagrammed first if the argument also contains a particular premise. Rule number 2. The letter X should be placed on the line dissecting an area if the whole area is so designated in the premise. Rule number 3. Only the premises should be diagrammed. And rule number 4. If the conclusion is self-evident in the diagram, then the argument or syllogism is valid. Let us consider this example, which is already in its standard form. All M are P. All S are M. So all S are P. Now, how do we determine the validity of this syllogism using a Venn diagram? Well, first, we need to draw 3 intersecting circles, that is, circles for S, P, and M, and then number the areas by starting at the center and then clockwise. Now that we have drawn 3 intersecting circles, each for S, P, and M, our next task is to diagram the syllogism. Let us start with the first premise, that is, all M are P. It must be noted that since the premise talks about the circles for M and P only, so we will imagine that the circle S does not exist. Hence, we will diagram M and P only. Now, since the premise says all M are P, that is, all members of M are members of P, then we will shade areas 5 and 6 to show that all members of M, which are areas 1 and 4, are part of P. The Venn diagram of the syllogism now looks like this. After we diagram the first premise, let us proceed to diagram the second premise, which reads, all S are M. This time, the premise talks about S and M only, so we will imagine that the circle for P does not exist. Now, since the premise says all S are M, that is, all members of S are members of M, then we will shade areas 7 and 2 to show that indeed all members of S, which is area 1, are part of M. Now the diagram looks like this. Since the Venn diagram of the syllogism is now complete, let us proceed to analyze the diagram to determine whether the syllogism is valid or invalid. As rule number 3 says, we diagram only the premises. Hence, we do not diagram the conclusion. And as rule number 4 says, the argument or syllogism is valid if the conclusion is self-evident in the Venn diagram. Now the conclusion says, all S are P. As we can see in the Venn diagram of the syllogism, this conclusion, all S are P, is perfectly diagrammed. That is, it is self-evident. In fact, since areas 2, 6, and 7 are shaded, then they do not exist anymore. What is left now of the class S is area 1, which all belongs to P. Thus, this syllogism is valid. Let us consider another example. Some M are P. All M are S. So, some S are P. And so, let us draw 3 intersecting circles for this syllogism, each for S, M, and P, and then number the areas by starting at the center and then clockwise. As rule number 1 says, we will diagram first the universal premise if the syllogism also contains a particular premise. Since the first premise in the syllogism is particular, while the second premise is universal, then we will diagram first the second premise, that is, all M are S. The second premise says, all M are S. So we will shade areas 4 and 5 to show that all members of M, which are areas 1 and 6, are part of S. And so the Venn diagram of the syllogism will now look like this. Now let us proceed to diagram the second premise, which says, some M are P.
Compliments and compliments. Everyone just loved my presentation, and I only spent 30 minutes on research. Others spent days on this research presentation. What a waste of time. If only they knew about Liner. Research was so fun for me because Liner picked out the trusted pages among all the Google search results. Even before clicking it, I could see if the page had what I needed. And when I entered the page, I just went straight to the key point. There is always useful information. You just gotta know how to reach it. Download Liner now. Simple and free.
Since this is a particular proposition, then we will not use the shading method. Instead, we will place an X on the designated area. Since the premise says some M are P, and since area 4 is already shaded, then it does not exist anymore. Thus, we will place the X on the area 1 to show that indeed there is at least one member of M that is a member of P. The Venn diagram of the syllogism now looks like this. Now that the Venn diagram of the syllogism is complete, let us proceed to determine its validity. And so, again, rule number 3 says, we diagram only the premises. Hence, we do not diagram the conclusion. And as rule number 4 says, the argument or the syllogism is valid if the conclusion is self-evident in the Venn diagram. Now, the conclusion of the syllogism says, some S are P. And if we look at the Venn diagram, there is an X on area 1, which indicates that there is at least one member of S that is a member of P. Hence, the conclusion which reads, some S are P, is perfectly diagrammed in the Venn diagram. Indeed, the conclusion is self-evident, therefore, the syllogism is valid. Here's another example. Some M are P. All S are M. So some S are P. Let us draw 3 intersecting circles for this syllogism, each for S, M, and P, and then number the areas by starting at the center and then clockwise. As we already know, we will diagram the universal premise first, which is all S are M. Thus, the Venn diagram of the syllogism now looks like this. Then let us diagram the second premise, which says, some M are P. Since areas 1 and 4 are so designated in the premise, then we will place the X on the line that dissects areas 1 and 4 to show that the whole area is so designated. Hence, the Venn diagram of this syllogism now looks like this. Since the X is on the line that dissects areas 1 and 4, this gives us an inconclusive reading of the conclusion. For this reason, this syllogism is invalid. Indeed, the conclusion is not self-evident. It is not perfectly diagrammed. Let us analyze one more example. All M are P. No S are M. So, no S are P. Again, let us draw 3 intersecting circles for this syllogism, each for S, M, and P, and then number the areas by starting at the center and then clockwise. Now, let us first diagram the first premise, which reads, all M are P. The Venn diagram of the syllogism now looks like this. Then let us diagram the second premise, which reads, no S are M. The Venn diagram of this syllogism now looks like this. The conclusion of this syllogism, which reads, no S are P, asserts that no members of S should be a member of P. But area 2 of the Venn diagram, which is also an area of S but P, is not shaded. Thus, the Venn diagram does not perfectly diagram the conclusion. Indeed, the conclusion is not self-evident. Therefore, the syllogism is invalid. That's it for now. Thanks for visiting us today for another whiteboard discussion here at Philo Notes. Full transcript of this video is available at philonotes.com. And to keep you updated of our newest videos, simply click here and subscribe and tap the bell for notifications. Thanks! Take care!
You see, we edit a lot of videos every day, so we
We'll show you how to use Venn diagrams to test the validity of syllogisms. First, a little review of syllogisms and Venn diagrams. Syllogisms are arguments with two premises and a conclusion. A standard form syllogism includes a predicate term in the first premise, a subject term in the second premise, and a middle term in each of the premises, and a conclusion. The conclusion is a standard form claim, such as all S are P, no S are P, some S are P, or some S are not P. The predicate term in the conclusion must appear in the first premise. The subject term of the conclusion must appear in the second premise, and the middle term appears just once in each premise. Venn diagrams provide a way to visualize logical relationships between a subject and predicate in a categorical claim. Two circles are drawn that overlap, the left circle representing the subject and the right circle representing the predicate in the categorical claim. In a universal affirmative claim, such as all baseballs are round, the subject is baseballs and the predicate is round. Or to clarify the claim, we might rephrase it as all things that are baseballs are also things that are round. In Venn diagrams, the part of the circle where there are no examples of members of that category is shaded. So in this case, the left side of the circle is shaded. The center area represents all baseballs, and they are part of the category of round things. In the Venn diagram of an E categorical claim, the middle area where the circles overlap is shaded because there are no S's that are also part of the P category. In this example, we want the diagram to represent that there are no penguins that are also traffic cops, so we shade the middle area. To diagram the particular categorical claims, some S are P and some S are not P, place an X in the area of the circle where there is at least one example of that category. In this case, there is at least one S that is also part of the P category. No shading is used in particular claims, only in universal claims. Rabbit is the subject, so the claim says that there is at least one rabbit that is a vicious killer. To diagram the O claims some S are not P, the X is placed inside the S category, but outside the P category. This indicates there is at least one S that is not a P. For instance, this would be the diagram of the O claim, some college students are not millionaires. To use a Venn diagram to represent a syllogism requires three circles because there are three different terms in a syllogism: the subject, predicate, and middle term. Since the circles form more overlapping areas, it is convenient to number the areas for easy reference. Usually, the numbering begins with the top circle, which represents the middle term. Let's walk through the process of diagramming a syllogism with two premises that are A claims. The conclusion is never represented in a Venn diagram of a syllogism, since the conclusion of a valid syllogism is the result of the premises. The conclusion is what the Venn diagrams should say after we diagram the premises of a valid argument. Although the conclusion isn't diagrammed, remember that the subject and predicate terms of a syllogism are determined by the conclusion. Here's the Venn diagram of the first premise, all P are M. Areas 6 and 7 are shaded to indicate nothing is there. The only P's are the ones in areas 3 and 4, the areas that are also part of the M category. So areas 3 and 4 are not shaded. Now let's diagram the second claim, all M are S. For all M are S, areas 1 and 4 are shaded to indicate that part of the diagram doesn't have anything in it. Just areas 2 and 3 remain, indicating that these are the only areas of M that remain. Now that we've diagrammed the two premises, we can check the validity of the conclusion. We just need to see if the conclusion is consistent with the resulting diagram. It isn't. The conclusion says that all of the S category belongs to the P category. But there are two areas of the S category outside of P, areas 2 and 5, so the syllogism is invalid. Let's test the validity of another syllogism, this time an argument that has particular claims in it. Some P are M, all M are S, some S are P. This is a syllogism with the mood I, and the figure 4. Remember that we indicate a particular claim in a Venn diagram by drawing an X in the appropriate area. The first premise says that there is at least one P that is an M. That means that an X goes in the part of the P circle that overlaps the M circle, areas 3 or 4. But which one? Area 3 or 4? Both are part of P that is also part of M. If we don't know which area to put the X, we draw it on the line between the two possible areas. Now for the second premise, all M are S. Remember that we said that the area where there isn't anything, which in this case would be areas 1 and 4, are shaded. So we should shade areas 1 and 4, but there's a problem. We've already added the X on the line between 3 and 4 to indicate it could be in either one, but area 4 is supposed to be empty. So we have to redraw the X and place it just in area 3, then shade areas 1 and 4. Now both premises are displayed. However, there is an easier way to draw them. If you have a particular and a universal claim in the premises, draw the universal claim in the Venn diagram first. Then you won't have to move the X. Is this syllogism valid? Does the Venn diagram say some S are P? Yes, there is an X in area 3 indicating that there is at least one S that is also a P. The syllogism is valid. In summary, use 3 circles in a Venn diagram to represent subject, predicate, and middle term. Number the circles beginning with the top circle. Draw the diagram to represent each of the two premises, but not the conclusion. If an argument has universal and particular premises, draw the universal premise first. Use an X to indicate at least one, and place it on the line between two areas if it isn't clear which side of the line it should be. After diagramming the premises, see if the conclusion is consistent with the drawing. If it is, the syllogism is valid. If not, the syllogism is invalid. Thanks for watching.
So that is for our week 16 topic and lesson. So if you have any questions, don't hesitate to ask. And also for some suggested readings and references, kindly refer to your handles or PDF files. For the video links that I have inserted in our PowerPoint presentation, I'll just post it in our GC or in our Google Classroom as well. So to end our week 16 lesson, I would like to say thank you everyone and share Bible verse from the book of Mark. Chapter 9, verse 23 said, Jesus, everything is possible for one who believes. So thank you once again, everyone, and see you on our week 17.